Probably the most important thing we're going to get into this section is what's called a proportion. Now, what a proportion is an equation with two ratios or two rates. So we would have, say, ratio 1 is equal to ratio 2. Now, what's going on here is we might have something like this. 2/3 equals, say, x over 6. Now, these are supposed to be the same ratio, or they represent the same relationship of 2 to 3. And this one's going to represent a similar relationship that, well, you could reduce it if you wanted to, the 2 to 3. But we need to find this missing number. What could it be? So the way we solve this kind of question is we cross multiply. And when we do this, we have 2 times 6 equals 3 times x. Now, we haven't talked about x yet. This is called a variable, or what's called a missing number. That's all the variables are. They're numbers. We'll treat them like numbers. I know we represent them using letters, but they're really numbers that we haven't discovered yet. So we're going to try to discover these numbers. So if 2 times 6 is 12, 3 times x, we call that 3x. Now, we're going to talk about more with algebra later, in fact, after chapter 5. So we're getting kind of a head start on algebra here. So if this seems a little confusing, it's okay. We're jumping ahead. The way algebra works is we solve for x. We discover what this missing number is by getting it by itself. And we do that using this idea of opposites. So opposites, specifically opposite operators. Operators are just things we do to numbers. We can add numbers, subtract them. Those are both operators. The opposites are addition, subtraction, and multiplication and division. So to get x by itself, we want to do the opposite of multiplying by 3. Well, the opposite of multiplication is division. So that means we can make this go away. We're allowed to cross it out if we divide by 3. And now we have permission to cross it out. That seems kind of like cheating in a way. It's like, wait a minute, you're just draw that there and makes the number go away? Well, not quite. You see, we do have to play by the rules. And the rules are this. What we do to one side, we have to do to the other. And we always do this with algebra. So this is 4. We have permission to cross this out. And that tells us what x is. And that's it. So suppose we have another one. Suppose we have this. Again, we'll cross multiply. And for these problems, we're always going to be dividing. So I'm going to divide by 5, divide by 5. Because it's the opposite of multiplying by 5, but also what I do to one side, I have to do to the other. And as a decimal, we could treat this as a decimal. This is 0.6. Now, this might seem kind of strange, but what it's saying is that 1/5 is equal to 0.6 over 3. And this is something with ratios and rates I want to point out. Unlike fractions, where we want whole numbers, in ratios and rates, it's okay to have decimal numbers in your top or bottom number. That is okay. It's another difference of between ratio and rates with fractions. Again, fractions, we only want whole numbers like we see with this ratio, and ratios can be like that too. They can have only whole numbers. But rates in ratios, they can have decimals, while fractions don't have decimals. So that is something that can happen. Let me do another. Suppose we have this. Again, we're going to cross multiply. So we get 5 times h equals 7 times 6. Or 5h equals 42. And it's customary in algebra to have, if you have a number and a variable or a letter multiplied together, to put the number first. It's just sort of a convention. Well, now we want to solve for h. So we can divide both sides by 5. Since dividing by 5 is the opposite of multiplying by 5, we have permission to cross that out. And then h, well, let's divide 42 by 5. It's going to be a decimal number, but that's okay. And we get 8.4. And that's it. So that's how you can solve proportions. Any questions? Let me know.